Download this code from codegive.com, link in the description below. Certainly. SQLite, PostgreSQL, and MySQL are all popular database management systems, but they serve different purposes and have different features. Below is an overview of each, followed by code examples to illustrate their differences. Overview. SQLite. Type ** serverless, file-based database. Use case ** ideal for small to medium applications, embedded systems, and applications that require minimal setup. Advantages ** lightweight and easy to set up. No server installation required, it reads and writes directly to a file. Transactions are supported, ACID compliant. Limitations ** not designed for high concurrency scenarios. Limited support for complex queries and advanced features compared to larger dbms. PostgreSQL. Type * object-relational database management system, ordbms. Use case * suitable for complex applications requiring advanced features, such as data integrity, concurrency, and extensibility. Advantages * highly extensible, supports custom data types, functions, and operators. Strong support for concurrency, uses multi-version concurrency control, MVCC. Advanced SQL compliance and support for complex queries. Limitations * more complex setup than SQLite. Requires more resources compared to SQLite. MySQL. Type * relational database management system, RDBMS. Use case * often used in web applications and data warehousing. Advantages * fast performance, optimized for read-heavy workloads. Widely used and supported, extensive documentation and community resources. Offers replication and clustering options. Limitations * historically had limitations in terms of SQL compliance and transaction handling, though these have improved in recent versions. Some advanced features may not be as robust as PostgreSQL. Code examples. Let's illustrate some basic SQL operations: create, insert, select, using SQLite, PostgreSQL, and MySQL. SQLite example. Python. Import sqlite 3. Connect to SQLite database, it will create the database file if it doesn't exist. Connection equals sqlite3.connect, example.db. Cursor equals connection.cursor. Create a table. Cursor.execute. Create table users. ID integer primary key. Name text not null. Age integer. Insert a record. Cursor.execute. Insert into users, name, age, values. Alice, 30. Query the records. Cursor.execute, select * from users. Print, cursor.fetch all, output, 1, Alice, 30. Commit changes and close the connection. Connection.commit. Connection.close. PostgreSQL example. Python. Import page 2. Connect to PostgreSQL database. Connection equals page 2.connect. Name equals example_db. User equals your _username. Password equals your _password. Host equals localhost. Port equals 5432. Cursor equals connection.cursor. Create a table. Cursor.execute. Create table users. ID serial primary key. Name varchar, 100, not null. Age integer. Insert a record. Cursor.execute. Insert into users, name, age, values, %s, %s. Bob, 25. Query the records. Cursor.execute, select asterisk from users. Print, cursor.fetch all, output, 1, Bob, 25. Commit changes and close the connection. Connection.commit. Cursor.close. Connection.close. MySQL example. Python. Import mysql.connector. Connect to MySQL database. Connection equals mysql.connector.connect. Host equals localhost. User equals your underscore username. Password equals your underscore password. Database equals example underscore db. Cursor equals connection.cursor. Create a table. Cursor.execute. Create table users. ID int auto underscore increment primary key. Name varchar, 100, not null. Age int. Insert a record. Cursor.execute. Insert into users, name, age, values, %s, %s. Charlie, 28. Query the records. Cursor.execute, select asterisk from users. Print, cursor.fetch all, output, 1, Charlie, 28. Commit changes and close the connection. Connection.commit. Cursor.close. Connection.close. Summary. SQLite is great for small applications and quick setups. PostgreSQL is suited for applications requiring advanced features and high concurrency. MySQL is often used in web applications and is known for its speed in read-heavy workloads. Choose the database that best fits your project requirements. Certainly. SQLite, PostgreSQL, and MySQL are three popular database systems that serve different purposes and use cases. This tutorial will provide an overview of each database, compare their features, and provide code examples to illustrate key differences. Overview. SQLite. Type: embedded, serverless, lightweight. Use case: ideal for small to medium-sized applications, mobile applications, and local storage. Storage: stores data in a single file on disk, making it easy to manage and distribute. Features: ACID compliant. Simple and easy to use. Limited concurrency support, one write, multiple readers. No user management or network access. PostgreSQL. Type: object-relational database management system, ordbms. Use case: suitable for large applications, complex queries, and high concurrency environments. Storage: manages data in a more complex way, supports various data types and indexing. Features: ACID compliant. Advanced features like JSON, GI support, and full text search. Strong concurrency support with MVCC, multi-version concurrency control. Extensible with custom data types and functions. MySQL. Type: relational database management system, RDBMS. Use case: widely used for web applications and online transaction processing. Storage: similar to PostgreSQL but often used with a simpler data model. Features: ACID compliant, with InnoDB storage engine. Good performance and scalability. Replication and sharding capabilities. Popular with LAMP stack, Linux, Apache, MySQL, PHP. Comparison table. Feature: SQLite, PostgreSQL, MySQL. --. Type: embedded, object relational. ACID compliance yes yes yes, InnoDB. Concurrency support limited high moderate. Scalability limited high high. Data types basic advanced basic. Extensibility limited high moderate. JSON support limited yes yes. Code examples. SQLite example. SQL. Create a SQLite database and a table. Create table users. ID integer primary key auto increment. Name text not null. Age integer. Insert data into the table. Insert into users, name, age, values, Alice, 30. Insert into users, name, age, values, Bob, 25. Query the data. Select asterisk from users. PostgreSQL example. SQL. Create a PostgreSQL database and a table. Create table users. ID serial primary key. Name varchar, 100, not null. Age int. Insert data into the table. Insert into users, name, age, values, Alice, 30. Insert into users, name, age, values, Bob, 25. Query the data. Select asterisk from users. Example of using JSON in PostgreSQL. Create table products. ID serial primary key. Data JSON. Insert into products, data, values, name, laptop, price, 999.99. Select asterisk from products where data-name equals laptop. MySQL example. SQL. Create a MySQL database and a table. Create table users. ID int auto underscore increment primary key. Name varchar, 100, not null. Age int. Insert data into the table. Insert into users, name, age, values, Alice, 30. Insert into users, name, age, values, Bob, 25. Query the data. Select asterisk from users. Example of using JSON in MySQL. Create table products. ID int auto underscore increment primary key. Data JSON. Insert into products, data, values, name, laptop, price, 999.99. Select asterisk from products where JSON underscore unquote, data $name, equals laptop. Conclusion. SQLite is great for applications requiring a lightweight, embedded database without the need for complex querying and high concurrency. PostgreSQL is the go-to choice for applications needing advanced features, complex queries, and high reliability with data integrity. MySQL is widely used for web applications and supports a variety of use cases, offering good performance and scalability. Choosing the right database depends on your specific needs, including the size and complexity of your application, expected load, and special features you may require.